and a choice that applies to our lives as data consumers and creators. Equity-oriented recognizes that we are multifaceted individuals with complex identities, and these identities shape our experiences with equity. Being equity-oriented includes an awareness of varying experiences with equity related to identity. And the reason I've highlighted this is a lot of my earlier work has really focused on anti-racism, and that continues to be a core component of my focus in my work. But there's certainly a lot of other issues related to equity that go beyond race. And I really want to include those in the conversation today when we're talking about responsible machine learning. And then data. What are we talking about when we talk about data? We're talking about lots of different things. We're talking about quantities, characters, or symbols used to represent or code knowledge in a form suitable for processing. So yes, we're talking about Excel spreadsheets, but we're also talking about data that might come from surveys. We're talking about location data that your phone is collecting. We're talking about the many tools that you interact with on a daily basis that leave a digital trace. We're talking about social media. We're even talking about your body. We're talking about your face. Facial recognition is going to capture your face and use that as data to make inferences. So when we're thinking about data really broadly. And an equitable and just world, again, this is what we're hoping to move towards, is a world where a collection of anti-racist policies can lead to equity and are substantiated by anti-racist ideas. And this kind of definition I pulled again from Ibram Kendi's work, and I really like it. And I linked it to a common image that's often used to show kind of the differences between equity and equality as well as justice. And it's this idea that, equality means that everyone has some equal access. And that doesn't necessarily reflect that people have different levels of access to begin with. And so equity in the second box demonstrates how, in this case, the individuals in this figure are provided with what they need in order to recognize that they're starting on different footing. Justice kind of gets to the idea that, well, maybe there shouldn't even be a fence at this baseball game at all. Maybe we should be working towards tearing the fence down. And then there's this idea that the Interaction Institute for Social Change put out for this idea of a fourth box and kind of, how do these concepts apply to your life? And I was really thinking about the fourth box, and this was in particular about a year ago that George Floyd's murder really got me thinking about what I could do personally as a data scientist. I think I thought a lot about kind of being anti-racist in my own personal life, but not necessarily in my professional life. And so I put together this piece that you can still find on Medium and on RTI's website called 5 Steps to Take as an Anti-Racist Data Scientist. I highlight this to note that I'll really only be talking about the 3 starred items in this presentation today, talking about educating ourselves about becoming anti-racist and equity-oriented, learning about how data and algorithms have been used to perpetuate inequity and racisms in the past, and eliminating racist and inequitable decisions and algorithms in our own work. But I do want to highlight that there are 2 other really key important pieces that I'm not talking about a lot today. And the first is committing to increasing diversity in data and analytics. People of color and people of diverse identities are pretty underrepresented in the field of data science. And so definitely looking towards opportunities to increase that diversity, as well as recognizing that it's important to contribute financially to Black-led and community-driven organizations committed to data awareness and increasing diversity in data science. And just a little plug, if you're interested in contributing financially today, Shayna has helped set up an opportunity to support diversity opportunities at the Institute for Advanced Analytics, which is hosting this conference. So I put out this article about a year ago and kind of, thought that might be a kind of a piece I would do, but then I actually got a lot of feedback on it. And a fair amount of that feedback was fairly negative. And so I've highlighted some of the comments that I received on this Medium piece here. And I get 2 critiques fairly often from this type of work. The first one is this idea that bringing up race is racist. And I think this comes from a place of people who are seeking kind of a colorblind world where we don't see race. And I think that ignores a lot of the complex history related to race and ethnicity, particularly in the United States. And so I encourage people with that particular critique of this talk and presentation to kind of dive into some of the literature related to, why we might not be seeking a colorblind world. But the second critique is one that kind of prompted me to do a lot more of these types of presentations and conversations. And that's this idea of, if you're actually a data scientist, why don't you just stick to the facts and statistics? And it comes from this place of seeing science as being objective and seeing that there's one truth. And this is something that I struggle with because, I agree that when you and I use the same math equation with the same inputs, we should get the same result. But if you and I look at the same data set and just kind of have a general, find out what you want to find out in this data, what is this data saying? We might come away with very different perspectives of what the data is saying. What story is it telling? And that's because we'll probably try different techniques. We'll try different things with the data. And the choices that we make about how we use the data and what we gather from it, how we interpreted it, and how we communicate those results, those are influenced by our own worldview and our own perspectives. So the things that I'll be talking about today, talking about educating ourselves about equity and anti-racism, eliminating racist and inequitable decisions and algorithms in our own work, some additional resources, and leaving time for discussion and questions. So you feel free to put questions in the chat. I'm going to address most of them at the end. So educating ourselves about equity and anti-racism. So I've kind of been leading towards this throughout this presentation, and that's this idea that you really do need to have an intentional mindset and to be making a choice. Yep, this racism thing is everyone's problem, including mine, and I'm going to do something about it. And this statement can apply to a lot more than just racism. This can apply to sexism, homophobia, ableism, and recognizing that, being in a space of working with data, particularly as a data scientist or analyst or statistician, puts you in a place where you can make this as a choice about the way you interact with data. I want to note that, I have not always been coming from this perspective. This was something that I grew into. I come from New Hampshire, which is a small state in the Northeast. Population about 1.35 million, and we're about 93% white. And this meant that as a child, I really didn't interact with very many people who didn't look like me. And so I have immense gratitude for a lot of the individuals and organizations that helped me along the journey so far to really recognize that, in this case, racism, but a lot of the isms that we're working with in society are things that, even though they don't necessarily apply to me, are part of the society that I live in. And I can make a choice to actively combat these in the work that I do. And so I really encourage you to think about where you are on your journey and how this might fit into your professional space as well. And kind of an idea of, what does it mean to have a limitation of your personal worldview? So this was something that actually came up on a recent project. I've got 2 calendars here, and I'm working on a dashboard that's going to be used in Ethiopia. And so it's built off of another dashboard that I'm already using in a different country. And so I thought it would just be fine to take this dashboard, use it in Ethiopia, and one of the key components of the dashboard is a date filter, so that you can filter by the calendar. And so by default, I just use the calendar that I'm really familiar with, which is this calendar on the left. But in presenting it to the client pointed out that the official calendar of Ethiopia is actually not the calendar on the left. The official calendar of Ethiopia is the calendar on the right. And this was a limitation of my personal worldview because I just had no idea that Ethiopia even had a different calendar. I didn't really know that there were places that had different calendars than what I was used to. And so this type of example I'm hoping to highlight because you don't know what you don't know until somebody has mentioned it to you. And so definitely having a kind of a growth mindset. There's a lot to learn, but also recognizing that there's always an opportunity to grow your worldview and become aware of different people's experiences and ways that they live in the world. And so kind of thinking about kind of going back to that objective piece from earlier, if the question that I had been asked as a data analyst was how many visits occurred in the second month of the year, I would have gotten a different result for using the US calendar versus using the Ethiopian calendar. because in the US calendar, there's 28 days in the second month. In the Ethiopian calendar, there's 30 days in the second month. So which result is correct? Well, from a mathematical perspective, both of these results are correct. The math of how many visits occurred in the second month is correct for both the US calendar and correct for the Ethiopian calendar. The question of which one is actually correct from the point of, depends a lot on your point of view. So from a reporting perspective, the correct result is going to probably depend on whether the person interested in the data is in the US or is in Ethiopia. And so it's this kind of idea of, if I looked at the data and if my coworker in Ethiopia looked at the data, we might have come back with two different answers to this particular question. So many of us have the honor and privilege of using data in the work that we do to share the individual and aggregated stories of people we will never meet. I really want to emphasize that I think it's crucial to reflect on and interrogate the ways that our personal worldviews shape the way we interpret and communicate these stories. And if we are in alignment with the worldview of the individuals who contributed the data and might be impacted by the results. One last piece just to mention here is related to kind of the idea of, where are we headed? And this comes from the Journal of Legal Analysis and is a really great piece on how we might regulate machine learning algorithms and algorithms more broadly. And it points out that the Achilles heel of all algorithms is the people who built them and the choices they make. It can be as simple as the choice, like I just pointed out, about calendars. It can be about predictors. It could be about training sets. But at the end of the day, a critical element of regulating algorithms is regulating humans. And again, that's because we bring our own worldviews, perspectives, and biases to the work that we do. So that brings me to my next phase, which is eliminating racist and inequitable decisions and algorithms in our own data analysis. Kind of leading into this, there's a lot of things coming out in the news related to bias and discrimination in algorithms. These are some of the some various news articles that I've recently seen. Everything from music recommendation algorithms increasing the gender gap to racial bias in healthcare algorithms to Twitter apologizing for a racist image cropping algorithm. And even in the bottom right, this was pretty big news when a facial recognition algorithm, faulty facial recognition algorithm, led to a man's arrest for a crime that he did not commit. So noting that there's a lot of conversation going on in this space. And so my hope in this next section is to kind of provide a loose overview of some technical approaches that you can use, particularly relevant to data science professionals and data practitioners at different phases of the data science workflow. So I've split the next section up into three parts: planning, implementing, and interpretation. And each section has a couple of examples and a couple of technical approaches, and they're meant to answer specific questions. And I will note in advance that the middle section is the longest. So this first section is the planning section. And I've got two questions here, and what I'm going to propose is two suggestions for how you might approach these results. And the questions are: who's represented in the data and who is involved in the planning? And by using these questions, I'm hoping that you can kind of think about how equity, bias, and anti-racism are being addressed in the work that you're doing. So that first question is: who is represented in the data? And this is from a predictive policing study. And I came across this study in some of the work that we do at RTI as we do a lot of criminal justice work. And this is a challenge that we think about pretty frequently. And it's the idea that, we work with criminal justice data from police databases, but police databases are not a complete census of all criminal offenses. Instead, and they don't constitute a representative random sample either, they reflect where policing is occurring. And historically, policing has occurred more often in communities of color and low-income communities. And so when we're thinking about predictive policing tools, this study pointed out that predictive policing is simply reproducing and magnifying some of the same biases that are found in historical data from police databases. And so when we do our criminal justice work, we think pretty critically about kind of what the base rates are for committing particular crimes and how we might adjust for those in the work that we do. So when you're collecting data, thinking about who is represented in the data And then the converse of that is who is not represented in the data. So considering the demographic variables available in the population, and are they representative of the wider population? And then that second question is who is involved in the planning? And this is also a criminal justice example, also something that was inspired by some work we did at RTI. It's the idea that, who is doing the planning for a particular project. And the example that I highlight here is that on some of our criminal justice projects, we've really thought about what an advisory board might look like. And in one in particular, we have an advisory board made up of formerly incarcerated individuals. And this has been a really crucial part of the project because these are persons who have had direct experience with the criminal justice system. And as we're working on some of the various research projects that we're doing, we really want to be conscious of these people's experiences because the perspectives they bring to the table are very different from the perspectives that we as researchers bring to the table, many of us who have not had experiences with incarceration. And so when you're kind of thinking about planning your project and thinking about, what is involved in the planning, what is involved in the analysis, what is involved in the communication, I really like this approach of including people who have experience with kind of whatever topic you're working on, because they'll be able to shed light and insight that you as researchers may not have thought of if you don't have personal experience with the issue at hand. So who is involved in the planning? What worldviews are represented in the project design team? What about in your research team? And acknowledging that there might be potential limitations for interpretation if you haven't captured the worldviews of the people who are going to be most affected by the work. So the second phase, the implementation phase. I'm not going to read through all of these questions, but just noting as I go through them that there's a bunch in here. So this is my longest section. So please bear with me. I also find that for practitioners, this can be one of the most helpful sections. So we're starting off with the question of, does this analysis explicitly explore impact by protected attributes? And if so, has the history, context, and purpose of these definitions been considered? So let's talk about race and ethnicity questions. This is one of the most common ways that race and ethnicity questions are going to be framed for a particular survey. And the reason why it's pretty common is it's kind of oftentimes defined by census categories. So the census is going to split race and ethnicity up into two questions, and they generally allow for selection of multiple races. But these questions are actually really challenging to work with. So one of the first reasons that people find these questions hard to work with is a mismatch between perceived and self-identity. And this is something that we run into when these questions aren't answered by an individual person, but are instead answered by an observer. So an example from criminal justice is sometimes a person's race won't be selected by the person being involved in the system, but some sort of observer is looking at a person and making a determination of what race they think that person is or ethnicity without asking that person directly. And that can lead to a lot of challenges in data interpretation because a person's self-identity may be different than their perceived identity. And in addition, when we're talking about life experiences, the same truth applies. Your life experience might be related to your perceived identity, racially or ethnically, but your self-identity might be different. And so when we're making statements about some of these racial categories, we're oftentimes saying, all Asian persons in our data set are sharing the same experience. And that may not be true given the difference between perceived and self-identity. Another topic to think about related to this is this idea of the one drop rule, which is kind of a legacy of racist structures in America. And the idea being that one drop, and I'd say that in quotations, noting that it's not really a direct measurement. But this idea that, if you are white and anything else, that automatically makes your experience non-white. And this can be a challenging grouping to identify with when persons who may be selecting multiple categories, again, may have mismatched expectations between their perceived and self-identities. Another challenge with these questions is large groupings of individuals that disregard geographic association. So I mentioned the Asian category earlier. This is one of the ones that gets a lot of criticism for grouping a very large population together when the experiences of individuals in that population may be really different depending on their geographic association. And another one is unclear categorization. And this is particularly true in the case of people who identify as Middle Eastern. And there's documented literature about how people who are Middle Eastern struggle to select a racial and ethnic identity that aligns with their lived experience. So if you're working with race and ethnicity questions or race and ethnicity data, it's really, really important to think critically about the limitations of these categories, many of which were invented by government bodies for purposes of data collection and don't necessarily reflect the experience that you might be trying to capture. And even more than that, it's also really important to think about the historical context for some of the definitions for where these categories come from. I'm going to highlight the definitions of Hispanic and Latino here. So these are terms that were invented by the US government, and they come from a 1976 law that requires collection of information about US citizens from Spanish-speaking countries of origins. Hispanic was first used in the 1980 census. There was some resistance to connections of Hispanic to Spain in the 90s, and so Latino was introduced in the 2000 census. And Latinx is a really more recent term that saw a substantial rise following the 2016 shooting at the Pulse nightclub. But on the right, you'll note that there's a lot of differing opinions on both the appropriateness of Latinx and the preferred term for a very broad community that reflects people from a lot of different countries and regions of origin. And oftentimes, these individuals are not sharing the same lived experience. So I really, again, recommend that, if you're working with the terms Hispanic or Latino or Latinx in some of your data, thinking critically about this history of where these terms came from. And again, some of the limitations and the interpretation of what you're actually saying from the data that you're getting. Which leads me to kind of this idea of the real question. And I really want to thank We All Count, which is a great organization that's working towards equity in data science. I went to a workshop where they talked about this idea of what are you actually trying to ask? And oftentimes when we're using race and ethnicity, the real question that we're trying to get at is marginalization. And this idea that people, particularly in the United States, have different lived experiences that have a relationship with their racial and ethnic identity. And so if you're trying to get towards marginalization, though, we should just ask about marginalization. So here's an example of a perceived marginalization scale. There are many other examples in the literature. So if you're interested in this, there's a lot that you can check out. But they're asking questions like, in your day-to-day life, how often are you treated with less courtesy than other people? How often do you receive poorer service than other people at restaurants or stores? How often do people act as if they think you are not smart, as if they are afraid of you, as if they think you are dishonest, or how often are you called names or insulted? And so this gives a better idea of kind of what experiences people are experiencing. And then you can ask a follow-up question, what do you think is the main reason? Or you can allow for selection of multiple reasons related to these experiences. So it includes race, but it also includes ancestry, gender, age, and kind of all of these other items in this list. And it recognizes that we all have really complex identities. And our experiences day to day are going to be shaped by these identities. And we're going to experience different degrees of marginalization because of them. So I encourage all of us as we're doing this type of research and thinking about equity and anti-racism and bias, especially when we're doing some sort of evaluation and data collection, thinking of opportunities to go beyond the historical race and ethnicity categories, and really trying to understand, well, what are we using those characteristics for? So this data includes different countries and protected attributes, such as race, ethnicity, and gender. I will note that the last discussion I had was mostly focused on the US. Globally, there are definitely different interpretations of race and ethnicity, as well as different histories. And so I encourage, if you're working with global data, to think about how they're relevant to the place that you're working in. Another kind of technical approach or something to think about, particularly if you're a data analyst or scientist, you might be working with a sample that has a variety of persons in it. And some of your sample sizes are really small. And so this is something that I'm asked to do pretty frequently as a data scientist. I'm asked to group ethnic and racial groups together because the data has come to me. I didn't get an opportunity to discuss a perceived marginalization scale, but I've been asked to use the data for some sort of analysis. Now it's on me to decide, well, looking at this table right here, I have 3 Hispanic, Native Hawaiian, or other Pacific Islanders. That's a pretty small number, and I probably am going to run into some sort of privacy concerns if I were to report data on this group. So then the question becomes, well, what do I do? Do I group Hispanic and non-Hispanic together and focus on the race categories? Do I group some of the race categories together and leave the ethnicity categories disaggregated? And I'll leave it that, unfortunately, I don't have a correct answer. I don't think there's one right answer. This kind of goes back to that objectivity piece. This could be done lots of different ways and they would all be correct. It's your kind of choice as a data analyst and scientist, as well as probably your teams, to decide on how you're going to respond to this. And so, the recommendations I have here is to first determine a decision in alignment with project goals. If your project goals are to compare differences between Hispanic and non-Hispanic communities, it's really important that you preserve that disaggregation. The second piece is to document your decision. So really, I think documentation is always important, but especially for a decision like this one. So, if later on people have questions, they can see what you've done. And the last piece is to communicate the decision. And I'm really looking forward to more communication around these types of decisions because I'd love for our community of practitioners in particular to discuss how we make these decisions and how we might make these decisions better. So you might need to collapse group levels of a variable to small sample sizes. Consider the differences in the worldview that you may be collapsing. The next one is what choices were made when using protected attributes for modeling. And this is a big one. And so oftentimes you might consider not including, in this example, race, but not including a protected class because you don't want your algorithm to be biased. And so the underlying assumption that's being made is that by leaving the variable out, your algorithm can't be biased because it's not in the algorithm. However, this has been shown to be incorrect. This is a really, really big example that was published in Nature. And it's this healthcare algorithm that's actively being used by doctors to make decisions about persons' treatments. And this particular one has found that millions of Black people were affected by bias in these algorithms. And the reason that this came up is the researchers said there was no race and variable and no close proxy of race in the algorithm. And so that was the rationale for why it couldn't be discriminatory. But the challenge was that the researchers hadn't accounted for embedded prejudice in projected cost. And that's probably because they might not have known there was embedded prejudice in projected cost. And so that was a piece of the algorithm, was projecting how much the cost of the healthcare treatment was. There's a discrepancy between Black communities and I think white communities. And then that led to this algorithm discriminating against Black people in particular. So really, really important to know that a decision to leave out a protected class when you're developing an algorithm does not necessarily mean you're going to have an unbiased algorithm. In this particular case, the researchers were able to go back and modify the model, which led to an 84% reduction in bias. But the big takeaway from this one, and you might have heard this before if you're a data science practitioner, is that fairness through unawareness, which is kind of the overarching principle of leaving out a variable, because you don't, if the model is unaware of the variable, it would be fair. But fairness through unawareness is not a sufficient condition to address discrimination. You can still have a discriminatory algorithm, even if you don't have the protected class or a proxy for it in the algorithm itself. Another choice that you're making as part of your algorithm decision making, if you were working on a logistic regression, might be your reference level. This is something I actually hadn't heard a lot of conversation before I added this to this presentation. But once I start talking to people, I think in a lot of introductory statistics classes, we don't talk about this enough. And so, logistic regression, I think I was often just told, just use the majority class, just use the most common class, and you're setting a reference level for a factored variable. And oftentimes this means that your reference level is white in a lot of categories for research in the United States. Not all projects, I shouldn't generalize too much, but frequently that's been my experience. And I think it's really important to question this decision. This example right here, we've got other racial groups compared to white for preeclampsia outcome. Maybe this makes sense for this particular project, but maybe it doesn't. And so if you do a lot of logistic regression, I really encourage you to think about, do you default to white every time? Because if you do default to white, is it because it's the most common, or might there be other opportunities for setting a reference level? And you can think about this in relation to gender, religion, lots of other topics as well. What is your default? Why is it your default? And is there a more equitable or anti-racist approach that you could consider? So mentioning here, fairness through unawareness is not enough, and considering the reference level for regression. Model interpretability is our next piece. We've got two more sections to this middle part. Interpretable models. I'm hoping we'll be talking a lot about this the next 2 days. That first reference is from Cynthia Rudin, who will be presenting later, which is super exciting. There's a lot of active work being done in this space, and that's the idea that you can choose a model that's not a so-called black box model. So black box model generally means that you're not really able to see under the hood and see exactly what the model is doing. An interpretable model means that you're better able to understand exactly what factors are important and the degree to which they're important. And Cynthia Rudin, Dr. Rudin's done a lot of really cool work in the space. So definitely encourage you to check out her presentation for a deep dive into this, because I'm just going to touch the surface with the idea that this is an important choice for the modeling work that you might do. And you can choose something that's more interpretable than another algorithm. And oftentimes, I'll say that for some of my projects in particular, we've been asked to do more interpretable work. I think an example I'll give is on a project where we are predicting the cause of death for infant mortalities, for infants who died in low and middle income countries. And we've been explicitly told that we should use interpretable models rather than just the best machine learning model, because the researchers want to understand how the model is making its decisions and how that aligns with how humans currently make their decisions. So I think that from an equity and an anti-racist perspective in particular, when you're building models that are going to impact people's lives, it's really important that you know what they're doing, so that you can figure out if they're making mistakes. And again, Dr. Rudin's done a lot of work, particularly with criminal justice algorithms in that space. So we are down to our last one, how model is being evaluated for current or future bias. So, we put together our algorithms, we've thought about the data that went into it, and now you've got your results. And there's a lot of really interesting tools also coming out related to how you might evaluate your model results. And I say this because, as somebody who's doing data science a lot, I really appreciate having tools that I can go to, because it just speeds up the process and makes it a little bit easier for me to analyze outcomes for bias and fairness. And so this one I'm highlighting comes from the University of Chicago. I believe the professor developed it at Carnegie Mellon now, but really cool free public resource that you can use to evaluate a number of different bias metrics. And it's got an explanation for those metrics as well. I hear there's another number of other things that are in the works. I think Google's got a couple of things as well. So yeah, if you got a data set and you're like, I want to know if it's biased, highly support that. I really encourage people to do that, particularly if you think that there's an opportunity for it to be biased in some way, and know that there are tools that you can use to evaluate bias in a data set. Why is it important to evaluate bias? One example here comes from 2016, and this is Microsoft developed a chatbot the idea was to use the chatbot to show how far natural language processing had come, which was true. It's come a really far way. But this chatbot, which was named Tay, was found by a certain corner of the internet that decided to feed it a lot of racist and homophobic and anti-Semitic and sexist information. And so within about 24 hours, the bot was just returning all of this language, and Microsoft had to shut it down. And so this was kind of an important piece, when you're doing this model building process, thinking about particularly if you're working on a machine learning algorithm that's going to continue to learn and update, what are the ways that it could be used for negative things in the future, and how might learning shape what it's going to produce. And so if you're interested in this type of conversation, there's a lot of work in the adversarial debiasing and responsible machine learning space. I think we might be talking about some of these topics too over the next 2 days, but noting that just because you put something out into the interwebs or wherever you put it doesn't mean that it's going to not be free of bias forever. And one saying I hold on to is that good intentions are not enough. Just because we're really well intentioned as data scientists, consumers, and professionals doesn't mean that we couldn't build something that is going to perpetuate biases and inequities. All right. So this is the middle section, that actually modeling and implementation phase. And the last one is the interpretation phase. So thanks for bearing with me. I've got 2 examples in here. The first one was who is involved in interpreting the results. And the second was how were the results communicated and distributed. So that first phase, who is involved in interpreting the results? So we've done, the planning, we've done the whole data phase, and there is still opportunity for bias when we get to that interpretation phase. And so the example I have here is of 4 departments at a university who are admitting and rejecting candidates, and they're split up between racial group 1 and racial group 2. And if you look at the lower green box, the lower table on the screen, the one with the orange and the blue highlights, you'll see that in the blue box, it looks like the admission rate for racial group 2 is higher than racial group 1. But if you look in the orange box, which is disaggregated by department, you'll see that in actuality, in every department, the acceptance rate for racial group 1 was higher than racial group 2. And you can certainly use the table at the top to check the math on it. But the important piece here is this is something known as Simpson's paradox. And the idea is that the result that you get kind of at the aggregate is different than the result that you get when you disaggregate. So as much as possible, I really encourage disaggregation when interpreting the results. Sometimes that's not feasible, but particularly when it's related to Simpson's paradox and drawing conclusions, you would come to a different conclusion, not necessarily incorrect depending on your perspective, but you would come to a different conclusion if you use the results from the blue box rather than the results from the orange box. And that last question, how are the results communicated and distributed? This could be a whole talk in and of itself. Many of these slides could be. I've actually attended a workshop on anti-racism in data visualization and communication. But the idea is that here too, there is opportunity to be anti-racist and equity oriented. So the example that I give here is kind of an older journal article where a researcher had gone back and looked at historical color use related to ethnic distributions and maps. And they'd found that there was effectively a downgrading of minorities by attributing them to less offensive colors or less intensive colors. And their takeaway was that map creators need to increase their awareness of color connotation and preferences when creating works that could be interpreted as assigning values or expressing likes and dislikes. And I would say the same applies to data practitioners. When you're developing some sort of visualization, I think oftentimes, in Excel or Tableau, it's really easy to go with the default color scheme, but take a moment, particularly if you're reflecting some sort of protected class like race or ethnicity or gender, and ask yourself, do these default colors reflect some sort of connotation or preference that might not be appropriate for this particular setting? So yeah, I think that just greater awareness of what we're putting out and taking a moment to think about also the language that's being used, or shapes. I really think that we're thinking about moving away from gendered shapes like men and women to better reflect that there's a lot of different ways that people might identify. So Again, there's a lot that could be done on this particular topic, but I do want to highlight just how important that communication and visualization piece is, because oftentimes that's how your work is going to be received by the community that first contributed the data. So yeah, consider the colors, language, and other choices in the visualizations you create, paying particular attention to any potential bias related to protected attributes. So I'm in the final phase of my presentation. I've left some time for questions, so apologies if I talk too fast, but feel free to throw some questions in the chat if something has come up. Individuals to follow, like I said, there's a lot of tremendous leaders in the space, particularly leaders of color and those that represent diverse backgrounds. Really encourage following these people on Twitter or LinkedIn or however you prefer to interact with research leaders. Joy on the far left was involved in or led the Coded Bias movie that's just now available on Netflix. So if you're interested in this type of space, check out Coded Bias on Netflix. It's awesome. Books to read. A lot of different books, lots of books coming out. So this is just a kind of a snapshot of these. If you're new to this space and really interested in it, I think Weapons of Math Destruction on the far right can be a really great introduction to it. It's got a lot of different examples of inequity in algorithms and responsible machine learning. Organizations to support, again, lots of cool organizations doing work in this space. We All Count in particular, I'd like to highlight. They host a lot of workshops. I've attended some of them. I think they're doing phenomenal work. And they also have a lot of resources that are particularly relevant to data professionals. So if you're looking to kind of get your organization to move in a particular direction, partnering with We All Count can be a really effective first step. Just some acknowledgements. I've had a lot of help developing this presentation and this work. I'd want to thank my RTI coworker, Nicole Mack, coworker from Duke, Kirshma Mahajan, the Institute for Advanced Analytics, which was the first place I actually really learned about responsible machine learning and ethics. We had a couple of speakers come in, including Tawana Petty, who was a couple of slides back, who were just phenomenal and really got me thinking about kind of how I wanted to incorporate this into my professional work, and Marsha Underwood at RTI, as well as the numerous individuals and organizations who contributed to my journey along the way. And so I'll leave you with a kind of concluding slide here, the same one that I showed at the beginning, this idea that being anti-racist and equity-oriented data scientists, analysts, creators, and consumers isn't a one-time decision, but instead a commitment we make each day towards building a more equitable and just world. And I'm hoping that something from my presentation resonated with you, and you feel like you can use it in your commitment towards building this more equitable and just world. So thank you, and we've got about 10 minutes left for discussion and questions. I'll go ahead and open the chat. Shayna, for more talk about responsible communication of data stories, tune into Sarah Egan Warren's talk at 4 p.m. today. Highly recommend that.
Just some shameless plugs in there from me. We do have one going back from Allison Young. Emily, do you have, or anyone, do you have any advice or experience in effective language or ways to approach conversations about cautions to the race-blind approach with researchers who use or develop predictive models in, say, a healthcare setting? It seems there are some instances where experienced researchers feel strongly about not including race. Is there some instances when this is the best option?
Yeah, that's a really great question. Oftentimes, particularly when I'm talking with researchers, they seem to really like it when I have sources that I can cite. And so there's a couple of great research articles, including the one I mentioned, that highlighted how leaving race out can still lead to biased algorithms. Another kind of area of research I definitely recommend is there's been a lot of conversation about lack of representation in samples used for healthcare research. They're not totally, I mean, they're random in a sense, but they don't necessarily include a diverse population. And then how that in and of itself is contributing to research that may disproportionately affect particularly communities of color and women. And an interesting piece was also pregnant women are oftentimes really underrepresented in research groups. So I usually start by finding some of the research and collecting literature, particularly when I'm talking with researchers, and then kind of, pushing back against that idea of fairness through unawareness, which I mentioned earlier, which is usually kind of that place that this is coming from. If our model is unaware, it can't be biased, but then highlighting that that's not necessarily true, because you you might not know which factors have a relationship with race until you look at it. And so that's the other piece, is that even if you're not planning to use race and ethnicity in the algorithm, I strongly encourage seeing if there is a way to collect that information, if that's what you're trying to determine bias based on, because you're not going to be able to evaluate the bias at all if you don't have that particular piece of information. So even if the researchers, hold off on including it in the algorithm, which might make sense depending on what they're doing, being able to have that data so you can do kind of a post hoc analysis to see if it's biased, or even just running correlations between the variables that were used in the model and race can provide some insight onto the likelihood that you're building a model that's biased.
Emily, I actually have a question. You talked about researchers defending their method because there were no close proxies of race in the data. To what extent have people thought about enforcing that, right? Making that provable? I could say there's no close proxies of race, but if I can predict race, if I can predict what race you are based on my other inputs, well, that's false, right? I would have a close proxy, even if it's all of the other inputs. If there is some, systemic thing that's been different over time between the different racial groups. So has that ever been considered as a way to prove that you have close proxies of race, is the ability to discriminate the different racial groups or different protected classes, really, based on other input attributes?
That's a really great idea, and I really like it. I know you tried something like that on a data set that we looked at earlier, and I totally support it. I haven't seen very much like that. So usually the conversation that I see is, well, we don't have race, and we don't have zip code, and we don't have, some sort of masked race or something like that, so we must be good. And I think that oftentimes reflects people's, again, own personal worldview of what is a proxy for race. And so from that example I gave earlier, I think that the researchers just had no clue that, or no idea that projected cost might be a proxy for race. And I'm guessing that one of the reasons they just never tried what you said, which is effectively predicting race based off of the categories that you have. So yeah, I think that would be a definitely an improvement and a better approach, because it gets rid of kind of, again, that perspective and worldview of what is a close proxy of race. Well, we actually don't necessarily know. Personally, it's not going to be intuitive, because there is so many different ways that racism is reflected in our society, some of them unanticipated.
Yeah, it seems to me like that might, and I don't know if anyone else here might have any input on that. It seems like maybe a good thing to add to the workflow, a modeling workflow, is to attempt to predict protected classes.
I love it. We should teach it in Stats 101 classes. And that's a big piece of it, is I think a lot of this material wasn't covered in my Stats 101 class, and I would love to see more of it talked about, because I think, again, as people, if you're on the call as a practitioner, sometimes you're just given a data set and told to do stuff with it. And you might even go back to your old Stats 101 notes and be like, well, what were the steps that I took back in the day? Or a Medium article. And I think that I would love to see this as part of that process.
Great. Does anyone else have any questions for Emily? All right, we will take just a short break and come back with Irene Chen in about 7 minutes.
Thanks, everyone.